Hi everyone, so hari ni kita nak buat soalan nombor 10 dekat dalam tutorial 7 kita. So jom kita tengok. Dia bagi kita, an object of 500 grams is moving with a simple harmonic motion, and then the distance between two consecutive points at which the speed of the object is 0 is 6.4 centimeters. The time taken for the object to move between the two points is 0.12 second. So jom kita tengok apa yang dimaksudkan dengan two consecutive points. So ceritanya begini. So two consecutive points boleh jadi daripada equilibrium to the next equilibrium korang. So in other words, two consecutive points from equilibrium to the next equilibrium, the neighboring equilibrium, or from amplitude to the other amplitude. But the problem is with the amplitude, the neighboring amplitude is this one, which is the negative amplitude. So it is actually from amplitude to the negative amplitude, ataupun daripada negative amplitude to the neighboring amplitude, which is the amplitude, the positive amplitude. So that's the meaning. So in this case, kita tahu yang ini ialah kita punya displacement. In this case, it is in centimeters. Yang ini ialah kita punya time in second. So dia bagi kita dekat dalam soalan ni tadi, dia kata masa daripada two consecutive point ialah 0.12 second, and then the displacement ialah 6.4 centimeters. So apa benda tu? So it's basically kalau daripada sini pergi ke sini, it is 0.12 second, like that. Ataupun maybe daripada amplitude ke negative amplitude ni, this one is also 0.12 second. And then the displacement tadi yang dibagi kita 6.4 cm tu ialah daripada amplitude tadi kan, from one point to another. So it is from the amplitude to the next amplitude macam tu. So this one is 6.4 cm, like that. Sebab kalau kita nak kata daripada equilibrium ke the next equilibrium tu kosong kan. So it is logically from two consecutive points tu ialah daripada amplitude ke amplitude lah. So that would be 6.4 cm, like that. Okay, but in terms of time, it can be lah from equilibrium to another equilibrium, ataupun daripada amplitude to the negative amplitude. So itu kita punya 0.12 saat. Faham tak? Right, so soalan pertama kita, dia kata calculate the frequency of the motion of the object. So kalau kita ingat back semula, frequency sama dengan 1 per period. So sekarang kita nak cari period dulu korang, sebelum kita boleh cari kita punya frequency. So based on this diagram tadi, kita dah tahu daripada equilibrium ke equilibrium ialah 0.12 saat. Tapi ini belum cukup satu period. Satu period ialah satu pusingan lengkap. So ini kita punya period. In other words, apa yang kita kena buat to get the period is T equals to 0.12 kena darabkan dengan, kena darabkan dengan 2. So kita akan dapat 0.24 saat. And then from there baru you boleh dapatkan you punya frequency. You can give it a try yourself, do the substitution, and you should get the answer as just an answer. Okay, right, the next question dia kata calculate the maximum speed of the object. I believe that you can do this yourself, no problem. I don't have to show it to you, just use the equation given in the notes. Okay, question C, also you can do it yourself. Calculate the acceleration of the object when the object is equal to 1/3 of the maximum value. So apa yang dicakap kat sini ialah bila y sama dengan 1/3 amplitude kita. So you just put it into the equation and you should get the answer. Give it a try, okay? And then question D also you can give it a try yourself, assuming that the object moves at equilibrium. Maksudnya itulah graph sign korang. Sebab kan graph sign kan memang sentiasa start daripada equilibrium gitu kan. Okay, so you use the pattern of y equals to a sin omega t, and please don't forget bila you dah buat apa dia punya jawapan tu kan, amplitude kan kita dah dapat, kita boleh dapat. Kejap lagi saya tunjukkan macam mana dapat dia. Don't forget the statement where displacement, apa boleh hilang, where displacement is in apa, centimeters, meters, inches, and time in second. Yeah, give it a try. We're gonna discuss it in our face-to-face class. Okay, we've seen it 2 times. Kita nak kena cari amplitude kita dekat sini. So macam mana nak dapatkan amplitude sebenarnya? Balik semula dalam keadaan ni, kita nampak tadi kan 6.4 cm kan. So kita boleh dapatkan kita punya amplitude sebenarnya A sama dengan 6.4 kurang bagi je dengan 2. Sebab memang daripada amplitude ke negative amplitude ialah 6.4 cm. So bahagi je lah dengan 2 and then you should get the answer of, is it 3.2 centimeters? Yes, you do that and then the rest of it is quite easy for you to do. Okay, now I want to focus on the last question, which is question E. Yang dikata kat sini, on the same axis sketch the graph of kinetic energy, potential energy and the total energy against displacement, and then indicate the value of amplitude and total energy on your graph. So you should get your amplitude already, and now we want to get the energy first, the total energy. So what we're gonna do is we're gonna do our graph like this. And don't forget the label, energy in joule, and then displacement in centimeters, if I'm not mistaken. I think that by now you should get the value of the amplitude yourself. Okay, in this case we have 3.2. I think this one is in centimeters, good, because the value given here is 6.4 centimeters. So I think that this one is in centimeters. Okay, now we want to focus on to get the value, of the total energy. So equation for total energy, siapa tahu? 1/2 m omega squared a squared. So you add in the value, the mass is already given, which is 0.5 kilograms. The question gave us 500 grams. So yeah, you change it into kilograms. Omega, you got it from the frequency. You can get it from the frequency because omega equals to 2 pi f. Yeah, and then the amplitude you got it from the previous question, and then the answer should be, yeah, this one, 0.175 joule. Okay, so you're gonna add in 0.175. Okay, it's quite ugly. Let me erase that. It is 0.175. Just add in there, and then our total energy graph should be like that. And then this is, don't forget the label E, and then our kinetic energy graph. Okay, I need to change this one. It doesn't work. Okay kids, yeah, just assume like that. Don't forget to put in the kinetic energy label, and then on the same amplitude we're gonna get maximum potential energy at amplitude and 0 at equilibrium. So yeah, that's the value. That's all.